Okay, so we are doing our second lesson. So create a new circuit. Okay, get your Arduino. Okay, so we'll start by, so right now I want to practice inputs and some simple outputs. So we'll just have, we'll put 3, 4, 5, 6. Okay, so how about we put 6 LEDs here? Okay. Okay. Okay, so first thing off, let's put a resistor. We'll rotate that, so Shift R. Go here. Okay, now we'll take an LED, rotate. Okay, so we want the flat edge facing up, right? That's your cathode. Okay. Okay, so Control C, Control V, right? Put them in a sequence here. Something that looks like that. So 4, 5. Could leave it at 5. It'll look nicer. Okay. Take a wire the cathodes all together, right? So make sure it lights up red, so you know you're getting it, right? You see what it just did here, right? You need to wait it's red, click, go and wait it's red, right? You see that? Red, here, good. So these are all connected, right? Connect your resistor, bring that to the ground, give it a nice curve. Okay, value of that, we'll make it, so that's in kilos, so let's go 0.2, so 200 ohms. Okay, now each of these are going to go to these 5, so let's do 7 to 3. Okay, so no need to be fancy here, you can make it nicer, but it's not a big deal. Okay, so you see that? Okay. I'm spacing them out this way because otherwise they overlap, and then I've tried in the past and they're not very good. It's easy to lose track. Okay. Okay, so those are wired. That's good. Let's put a push button. Put it here. Rotate it. 1, 2, okay, so that's good. How about we use 13? No, we'll use 12. Okay, so let's go around, curve that guy here, here, and we'll go to the ground. No, we'll go to +5. Right? We'll go here. And we'll put a pull down resistor. So we'll go here. So this is on. Okay, so it's getting a bit busy, but that's okay. So we'll put it on pin 12 here, right? So I'm just connecting here, and then we'll connect to the ground. Well, so see that wire here, it didn't work, right? So it's got to turn red. Okay, this we'll put at about 10K. Okay, so what this guy does, it just gives input 12. We'll configure it as an input, a ground, right? But then when we'll push on our button, it will read a 5 volt from on pin 12. So that should work here. I think we're ready to code. Okay, so let's make this much bigger. Okay, let's get this a bit smaller. Okay, so that's all we need to see, really. Let's bring this to the side. Okay, so we need to set up our pins here as outputs, because they are digital, right? So as outs. Okay, so we need to set those up here. We'll copy paste that 5 times, right? Actually 6, right? Because we got our input. 4, 5, 6. Okay, so pin 12 is input. The rest are outs. That's good, but we need to label them 7 all the way down to 3. 7, 6, 5, 4, 3. Okay. So what I'm doing here, it's a common cathode setup. It's the same as what we had with our 7 segment, right? I'm just breaking it out, right? So that's a common, right? I can change that to cathode, but it's individual. It'll be linear, right? So it won't be complex. We don't need that. That's just to show code. All right. So our setup section is ready to go. That's easy. Okay. I always like to teach you guys to go in steps. Don't try to plunk so many things all at once in one shot. Break it down into your simpler steps and then tie them up. Because if you put too much all at once and it doesn't work, which is likely to happen, even for myself, right? It's going to be harder to debug versus if I do little building blocks. I start with the most easy, simple, but foundational item. Then I work on this one until it's good to go, and then I can build on it, right? And this is just good practice, okay? So keep that in mind. So let's just do a test. So is that working, right? So just, can we get 7, right? LED on 7 to blink, right? So I'm just changing the inputs. Let's put that to 500 just so it's faster. It's just a test. It should work right away. 7, right? So we see that. It's working great. Okay, so good to go. My outputs are working. It should be good to go. Okay. All right. I think, right, so now it's just a matter of playing with our LEDs here, right, to confirm that they're all working, right? So that we'll deal with that later. So how about we go straight to our switch button here, to our push button. So let's forget delay. We'll just comment this out. Oh, come on. Oh. Okay. So let's just be able to read the push button to light 7 right now, okay? I'm just actually wondering if is there a really dirty way to get it in this bracket here. I've never tried that. Let's deal with that just later. So for inputs, you do a digital read, capital R, don't forget that. Bracket, you read from pin 12. I'm just going to double check my syntax here. Reference, Arduino, digital read. Okay, so you should do that. Reads the value. Oh, so we read the pin, right? So So you just give the number. Okay, so it's super easy, right? Yeah, so that means, I'm actually curious, I really want to try that now. I've never done it that way. So that means this might work. Putting it right into the state that I want to write. So I'm reading on 12, and then it's just going to loop. So it's going to write on pin 7 whatever it reads on pin 12. Wow, that's actually much faster if that works. Let's try. Wow. Okay, this is, yeah, because normally this is excellent. Okay, so this is a trick I've never done. I don't think it's that special, but it's something to be aware because normally I would have declared an integer, button, say, right? And then here do a digital read bracket of button, right? Semicolon. But then preface that by saying the variable button equals. So this is how I've seen it all the time. But this is a really quick and dirty way to get it in, right? One line here, right? So we don't need this line. And we don't even need this here. Okay, so really nice. Now for the next challenges that I'm asking you to do, you're not going to be able to use that. You're going to have to use you'll have to declare that integer here. It's just this is a nice trick to be aware of that can be used. Right, because we're always striving to keep our code the simplest, tightest possible. Okay, am I still recording? That looks good. Okay. So I think what I'd like us to try, and that's the single thing I'm going to show you. I'm going to give you a bunch of exercises to expand on it, okay? So we're going to uncomment that because we'll very likely need it. So let's just start with something simple here. Okay, I think we'll do two things. So first thing, are we able to light all of those lights up? LEDs when we push the button, basically, right? Making it the tightest possible, right? So so let's recomment that. That's super quick. So one way of doing it is we could just copy that, paste, right? 5 times, change the number. This is awful. Do not do that. This is what we call brute force. Well, brute force. Right, we could just change the number here. 6, 5, 4, 3. This is it does work, right? You could do it, but it's extremely ugly, right? So we'll just show it that it does work. Of course it will work. 3. Comment that. I'm still good to go. So every time I push, it should light all of them up. Right? See that? Okay. But it's awful practice. Okay. That's not what we want to be able to do. So how can we? This is where I'm trying to bring you to be able to conceptualize, to abstract, to make your code more abstract, right? So what are we doing here? Well, there's like a theme here, right? We're changing the value of the pin we're going to write to by 1, and we're doing it 5 times. We're going down 5 times, right? So how about we do a for loop, right? So this is what those things are for, right? So we'll delete that because that's awful. I don't want you guys to do stuff like that. If you give that to me in a quiz or a test, you're getting marks off. This is not right, like doing brute force. That's not the proper way. So you do a 4, so bracket, and then curly, right? This is our general structure. Let's plunk that. No, let's cut. Put it in. Okay. Here there's 2 semicolons. The first one is our init. So let's declare one of those integer I, right? That's why we use those. So let's call it. Let's start on 7, and then we'll write. You see the number 7 here? That's the number of the pin that I'm referencing. How about we just change that to I, right? So we'll digital write pin at the variable of that value, right? And so it will take the value of the variable and then it will just write to that pin. And so we can do a bunch of math like that. Okay, folks, this here, what I just did, like the idea that you use a number, a target, and I plunk a variable instead, this is the basics for all of coding. This is all it's about. And this is where it gets really abstract, right? Like this is just intro here, right? But we can stack abstractions upon abstractions, and this is where it gets beautiful. Okay. We're going to decrease, right? We're going to decrement our I. So remember, I've just showed the class online. It doesn't matter if you do pre or post, right? For your minus or for your plus. But many people say you're actually better off in front. So we'll keep it at minus I. And we want it to be done up to 1. So we want it to do it. We want it to be done until pin 3. So I has to turn to 2 to get off. Right? So I has to be greater than 2. Just want to confirm I'm doing this right. Right? That will be true, right? This is the part in the past that flared me, so I'm not going to do that mistake ever again now. It really burnt me. Right? That test here, that condition has to give true for the loop in 4 to run. So we want this to be true. So I will be higher than 2, right? 3, 4, 5, 6. So we're going to decrement and write those 5 pins with the state of my digital read. It looks like that should work. It's not very advanced. Look at that. Beautiful, beautiful, beautiful. Okay, so 1 line, and I'm writing, well, 4 lines, fair enough, right? Here's something you might not be aware of. C doesn't know those extra lines. It really just doesn't know, right? I could plunk all of this on the same line. Like this. You see that? That will still work. It has to. If it doesn't, something is not right. So it still works. Okay, so the compiler doesn't care that it's all in 1 line, because it just checks sequentially what's on your code and just interprets that, right? Could even have put that on the same line as 4. So why am I putting an enter? Well, you got it. It's for readability, right? It's to make your code readable, right? Okay. Okay. So that's easy. All right. So now for the more fun part. I'd like it to act like a trigger where every time I'll press the button, it will send a wave, right? Just one, right? Like click, 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 and then be done. Okay. And this is what I'll ask you guys to harp on, right? I'll ask you to build on those things. So for example, I'll ask you to make it come back. I'll ask you to make it go faster, right? As it goes, I'll ask you to catch it if it bounces back, when it bounces back with your button, and if you miss, to blink 3 times, stuff like that. It's just stringing your items together. Okay, so now let's focus on when I push my button, it will send a wave. So I will need those back here, my integer button, right? That's reusable here. We can reuse this. I have an idea here. Okay. Oh, we might not actually need this here. So let's actually start. So I'm thinking of using a NIF, but is there... Let's just double check our references here for the different controls. Reference Arduino. Is there a better structure that could work? So let's just think here before I go to that over. So I want that the minute the Arduino reads the button, it starts sending that wave. And that it has to be done for the button to restart. Now we could make that really fancy here, because we could make it that even if it's halfway, say, that if I press again, that it would restart. We could. That's where it gets really like fancy. Like there's many ways here to do this here, right? Let's not bother here that we can press it over. Let's just think, get it done, right? And we might have to tweak it. Okay, let's go back to our reference. Structure. Right, because if we use a while, so the while, okay, let's just show something here. The while, just make sure you pay attention to this here, right? So what the while would do is the minute I release my button, it will stop, basically. Digital read. Digital read, that's 12. Let's comment that back. Just want to show something here. Curly. Enter. Let's bring this in. Cut. Paste. Right? So push your items so you see that you feel that you're inside the while here, right? You see what I'm doing? Okay. So now it's starting to be a bit abstract, right? Right? Nothing to be scared of though. Okay. So here what will happen is the while should so essentially, as long as I'm holding my button, they will go through here, right? Because they will give me a true. This here, digital read, when I'm pushing, it reads a 1, a true. So it should start that sequence here. So digital write. Then we need our delay. Let's put not too long, something 500. And then we need to digital write low, right? Copy. Right, so here we're going to get rid of this. We're going to give it a high, and here we're going to give it a low. So why high, low? Because otherwise, Yeah, it gets interesting here. There's a lot of roads we can take. We need another delay here, otherwise it'll look funny. Okay, so this should write 76543 as long as I'm holding. Let's try it out. So and it will erase it as we go. Very nice. And if I drop, so see, because it enters the 4, right? Come on. Right. Okay, so let's get rid of this one here, just so that the effect is a bit faster. Okay. So it's not being it's not able to work if I like once it enters into the 4. Okay, that's giving me an idea. Let's try this out. Right? Right? Okay, so very nice. Very nice. Okay, I have an idea here. So let's stop that. So this section works. It basically triggers it, right? And then, okay, so that should work here. Let's actually insert a while inside that for loop. And then now, the minute we release our button, it should stop. So that means here I could have put a if. Let's try that. You see that? It did it just once, right? And then if I press, why is it doing that? Because now it's getting stuck in the while. Also, I would need to put a break here. Okay, let's put a break. Right. Let's just double check our... It's complex, eh? It's complex. Break. Let's just confirm. That's exactly it. Right, so you see this here? So a break is used to exit from a for, a while, or a do loop by passing the normal, right? So it'll force the code out. That's where you want to know your syntax. So the minute the delay is done, it needs to break, even though I'm still pushing on the button. And then it will do the next LED. Let's try that. And then release. Very nice. Okay. Very nice. What does it do if I hold it? It'll probably cycle. Yes. Okay, so I'm holding the button here. Okay. Okay, you guys have all the basics here in this little example to build all the examples I'm going to ask you to work on. Okay, so notice I've used a while here, a for, and here another while inside, but with the special break to force it to come out. Okay, so these might be useful features for you. Okay. Okay, one more thing I wanted to show. This should work with if. Okay. Yeah, because the only thing an if looks for is if it's true inside of the brackets for the test. So let's just double check. So the condition, right? So if it gives true, it's going to do what's inside. Let's see if it does a difference in terms of, so I'm kind of cheating here. I'm reading the value from the input here as a value. So when it's true, it's going to go into the if, basically. That should work. I don't see any differences happening. Let's check it out. So press, so it starts. Is it going to loop? Yes. And if I release, it's out. Okay, so you see, if and while, they're not necessarily, they're really similar in effects. Okay, now let's put an if here. That's probably going to work. So then it begs the question, when do you use one versus the other? Also see it gets stuck here. Also it doesn't like that. Okay, I would have to think a bit harder as to why. So do you see the kind of experimenting here I'm doing? Like, I don't do enough to immediately see the difference. I wish I did. Just be ready to experiment. I think that's what I'm trying to say to you guys here, is try various approaches. You have to come at it with the idea of testing ideas. So you have to go back to the while for this one. So I think what I'm trying to say is you need to know both, basically, right? Let's look at our structures. Is there one more we could try? So continue. I don't see that being helpful. A do while. Let's look at the continue. Oh, that could be helpful. Interesting. Okay, so right, so if you have a so this one, what it does is if you have a big loop happening and you want to skip a section here, right? If there's a certain condition that's met, you type continue and it's going to skip all that's rest inside of that given loop and go back to the top. It's not the same as break, because break gets out of the loop and goes to the next item outside of your loop. Okay, so it's not the same. So continue I could see that being handy. Okay, so just study it. Do while. Right, so that's one I've never used yet, but those are kinds of tricks and things you want to have under your belt, right? To know. So it's what it says here. It's like a while. The only difference is it will do the while loop at least once and then evaluate and test. So if you want something to be done at least once and then check, that's the structure you would use. So as I said, I've never used that. So good to know. And if those are obvious, the for we know. Return, let's look at that quick. Okay, you don't need that. That's when we do more complex functions. Okay, so that's not helpful for us. Okay, that'll be for grade 12. Okay, switch case. That one's kind of straightforward. Okay, so say for a certain number, right, you want something to happen, and for another number, right, say you're increasing numbers. So this is the structure here, and so you would check for a case and then break out. Okay, so that's helpful if, like, so say one time you push on the button, and so that'd be a great feature actually for the activity I want you guys to do. So say I push one time, it plays game 1, and then at the beginning, right, when I boot up, and say I press twice quick, it would check for case 2, right, and then it would do another game, right? So you could use that at the beginning, right, in the first 10 seconds. Read the button, how many times did you push, and then play game 1, game 2, game 3. This is just my mind going random here. This is an idea of how you could use that. Okay, I think it sums it up. Okay, so what we've seen is this. Okay, for loops are essential. Okay, you need to know how to use for. You need practice. Okay, so you need to try different ways. The decrements or increments, keep them at the front. It seems to be the more standard practice out there. A while and an if are close, so just be ready to experiment with either if you need to. A while is great for hanging in there, for stalling, as I've done in the past. You might need to use a break, as I did here. I think you got most items here. Okay, so we'll wish you good work. All right, so stay strong. All right, we see you in class.